In this video, I'm going to be demonstrating how to check the assumptions for a one-sample t-test, a paired sample t-test, an independent sample t-test, a one-way ANOVA, and a two-way ANOVA. Now, the first three assumptions on this list are used for every single one of these analyses. Because of that, we're going to start with the assumption of independence. For the assumption of independence, what you're assessing here is the research design. Specifically, you need to make sure that the data was randomly and independently sampled. If the data was randomly and independently sampled, then this assumption is met. If not, then it's not met. Now, if you don't have access to the research design, you can't really check this assumption. So if you're in a class, you're not really going to have access to this information. So what you could say is that you're going to give the researchers the benefit of the doubt and assume that their data was randomly and independently sampled. The second assumption for all these analyses is the assumption of scale of measurement. Now, all that this assumption is saying is that your outcome variable has to be on a continuous scale. That is either interval or ratio. The outcome variable cannot be nominal or ordinal. So it has to be on an interval or ratio scale. If it is on a nominal or ordinal scale, that means that you just have to choose a different type of analysis. These analyses are not the appropriate ones. The third assumption is the assumption of normality. Now, there's a few different ways to check the assumption of normality. So to start, I'm going to talk about skewness and kurtosis, as well as using a histogram. So to check skewness and kurtosis, you will obviously need SPSS. Once you get SPSS open, you're going to go to Analyze, Descriptive Statistics, and then Frequencies. Once you click on Frequencies, you should get a screen that looks just like this one. Now, if you go ahead and look in the left-hand box, you'll notice that that's where all of your variables are that you have in your data file. So what you'll need to do is find your outcome variable or your dependent variable. What you'll need to do is move it into the box on the right. Now, to do this, you could either double-click on the variable or select it and then click the arrow that's in the middle of the screen. Once you click on that, you'll notice that it goes into the right-hand box. Now here, I'm going to unselect Display Frequency Tables. Now when you unselect Display Frequency Tables, this screen will pop up, and all it's telling you is that nothing is currently selected to be run. So you could simply ignore it and just click OK, but then go into the other dialogues and select something to run. So for us, we're going to first go to Statistics. Now, when you click on Statistics, you're going to get a screen that looks just like this one. And you're going to want to click on Skewness and Kurtosis, just like I did. And then once you have Skewness and Kurtosis selected, you can go ahead and click Continue. After you click Continue, it's going to bring you to the main frequency area. And what you'll need to do next is click on Charts so we can get the histogram. Once you click on Charts, you're going to get a screen that looks just like this one. And you're going to want to find histogram, which is towards the bottom. And then you can click Show Normal Curve on histogram if you want. I like to show the normal curve, so I'm going to select it. Once you have all that selected, go ahead and click Continue. And then you could go ahead and click OK. And SPSS will run the skewness and kurtosis and the histograms. And this is what your output is going to look like. So if you take a look at the statistics table, you'll notice that that is where the skewness and the kurtosis lie. Now, if you remember, in order for the assumption of normality to be met, you want your skewness and your kurtosis to be in between plus and minus 1. So in this example, the skewness and kurtosis is a little off, but it's not too bad. So it's researcher's choice when it comes to a skewness and kurtosis like these. Another thing that I want to quickly point out is that you want to make sure that you report the skewness and the kurtosis not the standard error of the skewness or the standard error of the kurtosis. It happens frequently, so you want to make sure you look at the right area, not at the standard error. So you just look at skewness and kurtosis, not standard error of skewness or not standard error of kurtosis. Now, the second thing that we could use to assess normality is the histogram. However, you need to keep in mind that the histogram is simply a visual representation of what the skewness and the kurtosis is already telling us. So here, the histogram is showing us that there's some slight negative skewness as well as some positive kurtosis. Now, the second way to assess normality are through normality tests. And there's two normality tests. There's the KS test and the Shapiro-Wilk test. In order to get these tests in SPSS, what you'll need to do is go to Analyze, then Descriptive Statistics, and then click on Explore. Once you click on Explore, you're going to get a screen that looks just like this one. What you'll need to do here is find your dependent variable or your outcome variable. And once you find that variable, you're going to want to select it and then click the very top arrow button so it goes in the dependent list. Next, what you'll need to do is click on Plots. Now, after you click on Plots, you're going to get a screen that pops up just like this one. So what you're going to want to do here is unselect Stem and Leaf. You go ahead and click on Histogram if you want. This is just another way to get your histogram. You want to select None for box plots and then select Normality plots with test. That's what's going to run the normality test. So make sure you select that. Now, once your screen looks like this, you can go ahead and click Continue and then click OK. And once you click OK, SPSS will do all of its magic and run everything that you asked for it to run. Now, here's what the output will look like. In the descriptives table, it will actually give you the skewness and kurtosis if you just scroll down, and it's going to be the same exact skewness and kurtosis that you got above. So if you wanted to, you could do literally everything in the Explore function, but I wanted to show you both ways. Now, if you continue to scroll down, you'll find the test of normality table. And here you'll find the KS test and the Shapiro-Wilk test. So for these tests, you want them to be not significant. In other words, your p-value should be greater than 0.05. If the p-value is greater than 0.05, then that is suggesting that your dependent variable does not deviate from normality. In other words, it's normally distributed. Now, if your tests of normality are significant, what that's suggesting is that your dependent variable significantly deviates from a normal distribution. So in other words, your data is not normally distributed. So in this situation, these tests are suggesting that maybe our data is not normally distributed. After you've looked at the tests or normality, you go ahead and scroll down and there's going to be 3 plots. It's going to be the histogram and then the QQ plot and then another type of QQ plot. So you could also use those to help you with the assumption of normality. After you've checked the assumption of normality, you need to check the last assumption, which is the assumption of homogeneity of variance, which is also called the assumption of equality of variance. And to do this, what we're going to use is the Levene's test. Now, technically, you could get the Levene's test when you run your independent sample t-test or your ANOVAs, but I'm just going to show you how to get it beforehand, just in case you want to check it beforehand. So to get the Levene's test, what you'll need to do is go back to Explore. So to get there, you'll go to Analyze, then Descriptive Statistics, and then you're going to select Explore. Now, if you go back to Explore right after you've done the test of normality, your information is going to stay the same as you left it. So your dependent variable is still going to be there. So all you need to do is move your grouping variable over into the factor list. And after you've done that, you go ahead and click on Plots. After you click on plots, that same exact screen that we just looked at is going to show up. So what you're going to want to do here is unselect histograms, unselect normality plots with tests, and then select power estimation, which is underneath the spread versus Levene's test area. After your screen looks like mine, you can go ahead and click continue and then click OK, so SPSS will run the Levene's test for us. After you click OK, you're going to get output that looks just like this. Now, as I'm scrolling down, you're going to notice that the descriptives table looks a little bit different. And that's because what the descriptives table is doing is splitting up all the descriptives into the groups. So we have group 1, group 2, and group 3, and all of their descriptive statistics. But here, what we want to look at is the table that's right underneath that descriptives table. And that's where we're going to find the Levene's test. Now, for the Levene's test, we want it to be not significant. Because if it's not significant, what that's suggesting is that the variances between the three groups do not significantly differ. So we want our p-value to be greater than 0.05. If it's greater than 0.05, then the assumption of equality of variance is met. If the p-value is less than 0.05, then the assumption of equality of variance is not met. So if we look at our example here, the p-value is 0.014, which is less than 0.05, suggesting that the variances between the three groups significantly differ. In other words, the assumption of equality of variance is not met. And that is how you check the assumptions for all the types of t-tests, a one-way ANOVA, and a two-way ANOVA. If you have any questions, be sure to leave a comment, but if you're one of my students, you could go ahead and email me or text me.